Hello everyone, I welcome you all to this video of parametric differentiation. Okay, so parametric differentiation, what comes to my mind when I say the word parametric? I shall explain it to you. Parametric differentiation. Now, suppose let me take one example and explain it to you. X is given to you as cos theta. Y is given to you as sin theta. Question asked is find dy by dx. Okay, so now here, earlier we were solving the questions based on x, y, but now you can see something else is also there, that is theta. So here, that theta is called the parameter. Okay, so in your textbook you may have the parameters t or theta, only two. Now, how do I know that it is parametric differentiation? So what is the indication? Indication is you will be given x and y separate. So that is giving you the idea that it is parametric differentiation. Okay, so then how do I solve? So let me take that example and explain it to you. So now here, as it is, what we will do is we will differentiate. Remember, suppose I have y is equal to x square. Understand this concept and you will never go wrong. Y is equal to x square. So when I differentiate with respect to x, always you have to check the denominator. Always check the denominator. You are differentiating with respect to x. So therefore, you are writing dy by dx. So this is important with respect to whom you are differentiating. So here, therefore, your answer is 2x into this variable with respect to this. So it is actually dx by dx. This will get cancelled. Therefore, we are not writing it. Okay, but by chance you had y is equal to x square and the question was find dy by d theta. Understand this carefully. So now in the denominator you are differentiating with respect to theta. So what is your answer? It is 2x into now this variable x with respect to this parameter. So it is dx by d theta. Now it will not get cancelled. Understand, try to get the difference between the two. Okay, so now what we do is we directly find dx by d theta because the parameter is theta. So what is this answer? It is minus sine theta, correct? Then what is dy by d theta? This is equal to cos theta. Okay, so I kept ready dx by d theta, kept ready dy by d theta. So therefore, dy by dx is nothing but dy by d theta divided by dx by d theta. And what is dy by d theta answer? Be careful because you have found dx by d theta, don't write it on top. So that is equal to cos theta divided by minus sine theta. What is cos by sine? Cos by sine is cot. So answer is minus cot theta. So this is your answer. Very simple. Okay, so let us take another question. So if we have x is equal to 80 square, question is find dy by dx everywhere. 80 square, y is equal to 2at. How we are going to solve this? So here answer. So what do we do? Now who is a parameter? I can say the parameter is t. Okay, so t is a parameter. So dx by dt, if I take, a is a constant, right, as it is. What is t square's derivative? Is 2t. Next, dy by dt, what is it equal to? 2 is a constant, a is a constant, derivative of t is 1. So therefore, dy by dx is equal to dy by dt divided by dx by dt. So that is equal to 2a by 2at. 2 gets cancelled, a gets cancelled, you're left out with 1 by t. That is the final answer. So very simple, these parametric type of differentiation question. Okay, so let's take another question. Let us solve 3 to 4 questions. Okay, so that you get a clear-cut idea of how the parametric differentiation works. So take a third question. Here, the questions, the main question will be the same. Okay, find dy by dx. So here x is equal to a into theta plus sine theta. And y is given as a into 1 minus cos theta. Okay, so the question is clear. So how do I proceed now? Who is the parameter now? Theta is the parameter. Okay, so let me find out and keep ready dx by d theta. So that is equal to a is a constant, right, at as it is, put a bracket. Theta with respect to theta. Theta is like x. What is the derivative of x is 1? No, same way. Now, because you're differentiating with respect to theta, wherever there is theta, you are writing 1 plus sine theta derivative is cos theta. Done. Okay. dy by d theta. What is your answer? A, right, as it is, derivative 1, constant alone 0, minus cos theta derivative is minus sine theta. So therefore, this will become plus sine theta. So therefore, dy by dx is equal to dy by d theta. Who is on top? Dy. Okay. Divided by dx by d theta. So therefore, it is a sine theta divided by a into 1 plus cos theta. So here a gets cancelled. Now, you can't keep this answer as it is. Suppose by chance they ask, prove that dy by dx is equal to some answer. You have to reach that answer. And for that, you should remember 3 half angle formulas. So which are those half angle formulas? Quickly, let me tell you. So here, understand this. So suppose you have sine x. This you will get from the formula sine 2x. Sine 2x is 2 sine x cos x. Wherever there is x, put x by 2, you will get sine x. So sine x formula is 2 sine x by 2 cos x by 2. Okay. Then the second formula which you should know is 1 plus cos x. Whenever plus is there, remember cos will come. So it is 2 cos square x by 2. So how do you reach at this formula? Is from cos 2x formula in terms of cos. Cos 2x is 2 cos square x minus 1. Wherever there is x, put x by 2, you will reach this formula. Next, one more, you have 1 minus cos x is, whenever minus is there, remember sine will come to sine square x by 2. So these are the 3 formulas which you should remember. These are the tools to solve. So now substitute back. So therefore, this is equal to, so you have dy by dx is equal to sine theta. So what is the formula telling you? 2 sine. If x is there, write x. If theta is there, write theta. So 2 sine theta by 2 cos theta by 2 divided by 1 plus cos theta is 2 cos square theta by 2. So 2 and 2 gets cancelled, cos get cancelled, sine by cos, your answer is tan theta by 2. By chance they had asked you, prove that. So prove that dy by dx is equal to tan theta by 2. You have to substitute these half angle formulas and reach the answer. If you keep at this step, you may lose that last mark which that is given for the formula and simplification. Is that clear? So wherever they ask you, prove that question, you have to reach the answer by using the formulas. Let us take another question. Fourth one. Find dy by dx. Find dy by dx if x is equal to a into cos theta plus theta sine theta. Y is equal to a into sine theta minus theta cos theta. Okay, you have to be careful here when you solve this problem. Okay, so now suppose I have x. I take x is equal to a into, who is a parameter now? Theta is the parameter. So x is equal to a into cos theta plus theta sine theta. So I differentiate this. So therefore, dx by d theta, what is it equal to? A is a constant, right, as it is. Cos theta, what is the derivative? Is minus sine theta. Okay, now there are chances for students going wrong here. This is product rule. Please listen here. You have 2 terms, so use the product rule. Plus, put a bracket. First term into derivative of sine theta is cos theta plus second term sine theta into derivative of theta is 1. So now open the bracket. So dx by d theta is equal to a into minus sine theta plus theta cos theta plus sine theta. So plus sine theta minus sine theta gets cancelled and you are left with the dx by d theta is equal to a into theta cos theta. Next we have y is equal to a into sine theta minus theta cos theta. Let us simplify. So dy by d theta is equal to A, write as it is, sine theta is cos theta, put a minus and then product rule. Okay, put a bracket, otherwise minus will go only for the first term and you will get a wrong answer. So it is first term into derivative of second is minus sine theta plus the cos theta into derivative of theta is 1. Now open the bracket. So dy by d theta is equal to A into cos theta, minus into minus is plus theta sine theta, minus into plus is minus cos theta. If you don't put a bracket, then this term will not be cancelled. So therefore, dy by d theta, you are left with A theta sine theta. Okay, so simplification is over. Therefore, my final step dy by dx is equal to dy by d theta divided by dx by d theta. And that is equal to A theta sine theta divided by A theta cos theta. So A theta gets cancelled. So you are left with the answer tan theta. So if you learn how to differentiate, it is very, very, very simple. Okay. So I hope you are able to understand. Let's take another question. Let's take another question. The question number 5. Okay, so now here you will get through that type of question, and it is very, very important, very, very important, as I can tell you. Okay, so suppose you have x. So if x is equal to A into cos t plus log of tan t by 2. Okay, question looks little complicated, but it is easy. I will tell you step by step. And y is given to you A sine t. Prove that dy by dx is equal to tan t. So final step, anything you do, you have to reach that tan t. Okay, so when the answer is in front of us, we usually get the ideas how to reach that answer. Okay, ideas will flow. Okay, so let us see now. Let us work out carefully. Okay, so dx by d, who is the parameter now? T is the parameter. Dx by dt is equal to A, right, as it is. Cos t derivative is minus sine t plus log, now use chain rule, log x form. Log x is 1 by x. So it is 1 by tan t by 2 into, now go inside once again. This is of the form tan x. Tan x is secant square. So it is secant square. X means who? T by 2 into. Then go again inside. 1 by 2 is a constant. T's derivative is 1. Okay. So now simplify. So it is A into minus sine t, right, as it is. Who is 1 by tan? Who is a reciprocal of tan? Is cot. How do you write cot? Cos by sine. So you can write this as 1 by tan. No, you can write this as cos t by 2 by sine t by 2. Okay. Second is I can write cos is reciprocal. I can write 1 by cos square t by 2 into 1 by 2. Now 1 of cos t by 2 will get cancelled. What you are left with? A into minus sine t plus 1 by 2 sine t by 2 cos t by 2. Now, have you come across this formula, half angle formula? Do you remember? Sin x formula is 2 sin x by 2 cos x by 2. So therefore, in that place, you are writing the half angle formula. So this is A into minus sin t plus 1 by, this will become sin t formula. Immediately, what idea comes to my mind? Next step, take the LCM. So when you take the LCM, you are getting, so LCM is your sin t. You will get minus sin t into sin t is minus sin square t plus 1. And we know from the first identity, 1 minus sin square theta is cos square theta. So here it is cos square t by sin t. So this is, I can't simplify further, keep it as it is. So that was your dx by dt. Okay, somehow I have to reach that answer tan t. Okay, so now you have y is equal to A sin t. Find dy by dt and keep ready. So dy by dt is A into sin t derivative is cos t. So therefore, dy by dx is equal to dy by dt divided by dx by dt. And therefore, this is equal to dy by dt is A cos t divided by, what is dx by dt? A cos square t divided by sine t, that will go to the numerator. So into sine t. So now A will get cancelled, 1 of cos will get cancelled. You are left with sine by cos, which is equal to tan t. Okay, so that is the required answer which we have to prove. Okay, so go through the steps carefully. Step by step explanation I have given. So see that you get all the steps. Okay, so I will solve one more question in this, such that you get the ideas of all different types of parametric questions. So here, this is also an important question. They've asked us if x is equal to square root of a to the power sine inverse t, y is equal to square root of a to the power cos inverse t, prove that or show that dy by dx is equal to minus y by x. Show that dy by dx is equal to minus y by x. Okay, how do I solve this? So I can explain to you in two ways, but one type is very, very simple. You'll get answer in 3 to 4 steps. So what do I do here is I multiply the two equations. Suppose this is one equation and this is two equation, multiplying 1 and 2. Okay, what will I get? First, let me simplify. So the left side, I'm getting x into y is equal to root of a to the power sine inverse t into root of a to the power cos inverse t. Okay, a to the power sine inverse t into root of a to the power cos inverse t. So now here, what do I get? So now, first let me simplify. What is, suppose I have root x into root y. I can write this together as root of xy, isn't it? Okay, fine. So here, root of xy. So I will combine these two together. So xy is equal to, I will write as one root a to the power sine inverse t into a to the power cos inverse t. Now what comes to my mind? What is a to the power m into a to the power n? It is a to the power m plus n. Okay, so I can write this xy as square root of a to the power m plus n is who now sine inverse t plus cos inverse t. Okay, so now in inverse trigonometric function, the property says if whenever you add the co-functions of inverse, okay, so whenever you add sine inverse t plus cos inverse t, always that is equal to pi by 2. So therefore, xy is equal to square root of a to the power, and this is equal to pi by 2. That's it. Now I'm going to differentiate. So differentiate with respect to x. So when you differentiate, this is a product rule. Remember, it is first term into derivative of the second plus second term y into derivative of first. That is equal to, this right hand side is a constant. So therefore, the answer is equal to a 0. So therefore, your x dy by dx, keep it as it is, shift y to the other side, you are getting minus y, and you are left with the dy by dx is equal to minus y by x as desired. Hope you have understood thoroughly how to differentiate using parametric differentiation.